This lesson is on division of integers. So we're going to take 944 divided by 8, and before we go ahead and do that, I want to talk about is what does that mean and what is the symbol that we're going to use. We're going to use this long division symbol right here, and we're going to have a number on the outside of that long division called a divisor and a number inside of the long division called a dividend, and the answer on the top is called the quotient. So what does that mean for the 944 divided by 8? This denominator right here, the 8, is going to be called the divisor, and the numerator right here, the 944, is going to be the dividend part right here. Okay, and so then when we divide it out, we're going to have is the quotient, and sometime in our dividends it doesn't go in evenly, so we're going to have this thing called the remainder, so we'll add the remainder part of it. All right. Now, what a lot of students then get mixed up is the numbers, which is the numerator and the denominator part of these numbers right here, and where does it go in the division right here. So let me go ahead and show you the physical part of it. We take 944 and let's say we bring it over here and we rotate it 90 degrees to the right. What we're going to have is this thing 8 and 944 and the dividing sign right there. Okay, this is going to look like the multiplication part of the integers where we had the area modeling. So what we did was we took the height of something, the 8, and we knew the base of that. So we multiplied the two numbers together and we tried to find is the answer or the area modeling of this. For the division, you're going backwards. We know that the answer is going to be 944. We know that the height is going to be 8. And what we're trying to find out is what is this base right here number? Okay, so let's go ahead and spread this out because I know I'm going to work on this, and we're also going to put some divider in here, and the reason why is because then this goes back to same thing with the multiplication and addition and subtraction of integers that we did. We made this the units of ones right here, we made this the tens, and we made this the hundreds. So it's this exactly same idea. We're going to go ahead and divide it into 3 parts. So what we're doing is then we're going to take this height right here of 8 and we're going to say times something over here will give us the area that is exactly 9 or less than 9. It cannot be greater than 9 because if it's greater than 9, then that means the number up here has to be bigger than what you have chosen. Okay, so usually then I just go through the multiplication part of each of the numbers. So I would say then is 8 times something. So I would just say, for example, 1. 8 times 1 is 8. Okay, is that number less than 9? Yes. But is that the best choice? So then I would do 8 times 2 to see what that comes out to be. And 8 times 2 is 16. 16 is too big. It's bigger than this 9 right here. So 2 cannot be the best answer. 1 would have to be the best answer. So 8 times 1 we said was 8. And we're going to subtract the two numbers, giving us the 1. Now once we get this 1, we're going to take this 1 and we're going to bring it to the next column right there. So if you remember, it's similar to that borrowing that we did for the subtraction, but in this case we're giving it instead of borrowing. So we're going to give it to the tens column right there, and we're going to continue to go on and try to find the area of that. So we're trying to find is 8 times this base right here will give us the 14 right there. Okay, so we try again. 8 times 1 is 8. 8 times 2 is 16. 16 is too big because you want a number that is equal to 14 or less than 14. So we're going to keep that 1 right there and go 8 times 1 is 8. We're going to subtract the two numbers and get 6. So the same thing, we're going to give the 6 now. Instead of borrowing, we're giving it to the ones place. And we're saying here, take the 6 and give it a 64. So continuing on with this, we're going to go 8 times something over here in the base will give us close to 64. So I'm going to just go through the multiplication of this. So we know 8 times 2 is 16. Small, but is it closer? No, we probably can get more. So let's try 8 times 3. 8 times 3 is 24. Still, I can get more probably. So 8 times 4 is 32. Let's try some more. 8 times 5 is 40. I think I can get some more from that. 8 times 6 is 48. That's close. 8 times 7 is 56. Close, but let's see if we can get some more. 8 times 8 is 64. Oh, it's exactly the same number. So we're going to go ahead and use 8 times 8, giving us 64, and 0 is the final answer, which is perfect. That means when we do the backwards of this, the area modeling, 8 is the height right there, 118 is the base. If I multiply those two numbers together, the area should give us 944, because that was the original number, right? 944 divided by 8. Okay, so that's what it means for this division part. So let's try another number. We have is 4,212 divided by 36. So we're going to bring it over to the side again. We're going to rotate it 90 degrees, and let's go ahead and put it inside. So we're going to go ahead and divide it up into parts. We have is the ones column on the far right here. We have is the tens column, the hundreds column, and the thousands column, because remember this is 4,210 plus 2. Okay, so we're going to go ahead and say 36 times some kind of base number has to give us the 4. We have a problem because 36 is actually bigger than this 4 right here. So we can't do 36 times something that would give us 4. So since we cannot do that, we're going to, in this case, give it to the hundredths place. So if we give it, I'm going to take this divider out, give it to the hundredths place, and we're going to say 42 instead. So now 36 times some kind of base right there, closest number, that gives us 42 is what we're looking for. So again, we have to go through the multiplication. So 36 times 1 is 36. 36 times 2 is 72. 72 is too big, so we're going to keep the 1 and say 36. We're going to subtract the 42 from 36 and get 6 is our remainder. So now with the 6, we're going to give it to the tens place and give it as 61. So we continue to do the next part. We say 36 is the height, and the base is some kind of number that gives us close to 61 right there. Okay? So let's go through the multiplication again. So we said 36 times 2 is 72. That's too big, right? So we're going to have to keep that 1 again and get 36. So if we subtract those two numbers, we're going to get 25. This number is bigger than the divisor. That means we have to bump up our number for this part right here because it goes in more than what it's supposed to be. Okay, so now let's take the 25 and again give it to the ones place, and we're trying to figure out is now what is 36 times this base right here that will give us either exactly 252 or less. So 36 times 3 gives us 101. Still, we can get probably bigger. 36 times 4 is 144. 36 times 5 is 180. 36 times 6 is 216. It's getting close. 36 times 7 is 252. So exactly goes in evenly at 7, and it gives us 252. If we subtract those two numbers, we get a 0. Okay? So again, the area modeling says that if I do 36 times 117, the area of this should give us 4,212, right? Because that was the original number. Okay? Now let's try the last example. 3,218 divided by 15. So we're going to go ahead and put those numbers in. And if I create my sections, I'm going to have my ones again, the tens, the hundreds, and the thousands. So we try again. The 15 times something, right, has to give us the 3. We can't do that because 3 is small, so you can't create a large number that has an area that is smaller than the divisor out here. So we're going to go ahead and give it to the hundredths place and get 32 instead. So now we're saying 15 times something has to give us 32. So 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. So the closest number we're going to have is 2, because 15 times 2 is 30. So if we subtract those two numbers, we're going to get 2. So now we're going to take this 2, we're going to give it to the tens place right here, and we have this 21. So now we continue on. 15 times some kind of base number that is exactly 21 or less. So 15 times 1 we said was 15. 15 times 2 is 30. So that's too big, so we're going to have to use the 1. Get 15, subtract the two numbers, and get 6. So now we're going to take the 6, we're going to give it to the ones, and giving us 68. So now 15 times, we said 2 was 30. 15 times 3 is 45. 15 times 4 is 60. And 15 times 5 is 75. 75 is too big, so we're going to go with a 4, because 15 times 4 gives us 60, which is close. And then we're going to subtract those two and give us 8. Now the last two problems, these numbers right here went in evenly right here, and we got a 0. But in this case, we actually have is what we call the remainder. So when we have a remainder, we're going to go back up here, and remember we're going to add the remainder to it. So we're going to put an R next to it to remind us that is a remainder number after this, which is then the 8 number right here. Okay, so what does that mean? That means when we did the area modeling of 15 times 214, that did not give us exactly 3,218. It actually was bigger because we had some remainder part of it. Okay, so that's what we're looking for, is now we're going the opposite of the area modeling, and we're trying to guess is what is that base that's going to give us the closest answer to the area.